This is Laura Duncan with CSMS. Today we're going to be graphing inequalities in two variables. For the first step, we'll solve for y when necessary to get the inequality into sort of a slope-intercept form. We'll graph the line using a solid line for less than or equal to or greater than or equal to, and we'll graph a dotted line if we have less than or greater than. Step 3 will shade below the line if it's a less than or equal to. And finally, we'll shade above the line if it's greater than or equal to. So let's look at example 1. This is kind of like slope-intercept form, where the slope is equal to -2, and the y-intercept, or b, is 0, -3. So we'll graph that line, starting with 0, -3. Then using our slope, we will go down to the right one. Once you've plotted those points, using your straight edge, draw a straight line through your points. Once you've drawn your line, make sure it goes through your whole graph. Please put arrows at the end of your line. Now, because this is an inequality, all the figures, all the points on the line make this value true because it's less than or equal to. So it's a solid line because it's or equal to, and because it's less than, we're going to shade the area below it. So take your highlighter, and all of these points under the line are also included in this inequality. All of these points make the value true, and therefore they are solutions to this inequality. Let's go on to number 2. Notice that the slope of the line is 1/2 and the y-intercept is 0, -3. But this time it says that y is greater than. So in this case, we're going to have a dotted line, and since y is greater than, we're going to shade above the line. Let's begin with drawing the line itself. So we have the point 0, -3, that's where we'll begin. The slope is 1/2, so that would be up 1 over 2, up 1 over 2. Once you have about 3 or 4 dots on your line, then you may draw your line. In our application, I cannot draw straight lines, but you're going to use your straight edge. Since this is a dotted line, you'll draw a dashed line. Because y is greater than, we will highlight the solutions above the graph. So every one of these solutions are a solution to this graph. All of these points are solutions. They make the value true. However, the points on the line, such as the y-intercept, would not make the value true because these values on the line would be equal to. That's why it's a dashed line, kind of like when we had a single variable, we used an open circle rather than a closed circle. Let's go on to number 3. For number 3, you can see it's not written in slope-intercept form. So we're going to isolate the y so that we can make this into slope-intercept form. I'm going to rearrange it so that the x comes first, and I will divide every term by 2 so that the y will be isolated. Now for the equation, we have the slope is -3/2, and the y-intercept is 0, 3. This will be a dotted line, and we will be shading above the line. So let's start by drawing the line. Please put arrows at the end of your line. Remember, it's a dashed line or a dotted line, sort of like an open circle. Because y is greater than the expression, that means everything above the line will be a solution to this inequality. The points on the line are not a solution. Please pause the video here and try number 4 on your own. Remember to begin with slope-intercept form. All right, as you're going through this problem, did you hear something? You should be hearing bells, sirens, and whistles, because if you divide by a negative number, you're going to need to switch the sign. So now it will read y is less than 1/3 x plus 2. Since it's less than or equal to, we will have a solid line, and since it's less than, we will shade below the line. Please go ahead and graph your line. Please be sure to put arrows on the tip of your line. With my application, I'm sorry it's not perfect. However, your shading should show that we are going to be shading below the line. In this case, every solution that is on the line and every point that is shaded is a solution to this inequality. All of those are solutions. Let's turn to the next page. Looking at number 5 and 6, we have two special cases. When we have a y equals equation, we would call those HOYs, where we would have a horizontal line with 0 slope and a y equals equation. So when we have a horizontal line and y is greater than 3, we know that we're going to have a dotted or dashed line, and then we're going to shade above the line. So let's graph the line y equals 3. But this time when we graph it, be sure to use only dashed lines, since it's greater than, but not greater than or equal to. The solutions are going to be above that line, so let's shade above the line. Every point that is above this line is a solution to this inequality. Number 6 is very similar because it is also a special case where we have an x equals. When we have an x equals, we usually describe it as a vux, a vertical line with undefined slope and an x equal equation. Well, in this case, we're going to have a solid line, and this time let's wait to see the line before we decide if it's above or below. So we have a vertical line at y equals 4. Y equals -4. So go ahead and graph that line. And please put arrows at the end of it. Now in this case, there's no above or below. What we're going to look at, is it smaller or is it greater? So if it's smaller, it's going to be on the left side over here. If it's greater, then it's going to go to the right side. So as you can see, x is less than. So that means all these values to the left of the line, including the values on the line, will be a solution to this inequality. Looking at the last question, which of the following points would be a solution to this inequality? First, please put your line in slope-intercept form. We'll begin by subtracting 3x from both sides. I'm going to put the 3x first so that it will be in slope-intercept form. Then I'll divide by -1 on each side. Do you hear something? You should hear bells, sirens, and whistles, because we're going to have to change that sign since we are dividing by a negative. So our line is going to be a dotted or dashed line, and we will be shading below. Please pause the video and graph your line. Alright, you're going to draw a much better line than I did because I do not have the ability to draw a straight line on this application. You're going to use a straight edge though. So remember to switch the sign, and now we have where we need to shade. We will be shading below the line, so that means over here. And to check to see if a line or if a point is a solution, we check and see where it is. So we have the point -2, 0. That's why it's so important for you to graph very, very neatly when you're doing these. So the point -2, 0 is right here. So is that a solution? No, it is not. It is outside of our solution set. 4, 8. So you graph that point. And the point 4, 8 is inside our solution set. It is in the shaded section. So yes, it is. 0, 2. 0, 2 is right here. It is a point on the line. Since this is a dashed or dotted line, it's kind of like an open circle. It is not included in our solution set. So the only one that is included is 4, 8. This concludes your lesson for today.